Okay, in this video we're going to take a look at another way to solve quadratic equations. We're going to take a look at something called the square root method, which can also include completing the square to solve something. So in the last video we learned how to solve using factoring, and we did a question like this. By factoring this side to, it's a difference of squares, so x plus 2, x minus 2, setting each part equal to 0, and getting our answers, negative 2 and 2, or you could write plus or minus 2. And this we called the factor method. Now let's take a look at a way of doing this that takes x squared minus 4 and solves it using the idea of square roots. This is called the square root method, and you may have seen this idea before. So I isolate my square, so I get x squared on one side by adding 4 to the other side, and then I take the square root, and whenever you take the square root you get plus or minus the square root of 4, and this simplifies to plus or minus 2, and I can compare and I have the exact same solutions, x is plus 2 or x is minus 2, but I've used a new method, and we'll call that the square root method. So what I did there is I isolated a perfect square. I got x squared by itself. Then I took a square root of both sides, so I did the square root on this side, that gave me x, and I did the square root on this side. And when you take that square root on both sides, you just have to remember that you get plus or minus your solution. So this right here gives you either plus or minus. So let's see if we can use this new method, the square root method, to solve some slightly complicated, more complicated scenarios. So here I have 5x squared minus 10 equals 0, and I'm trying to solve this. So I get this squared part to one side, and I move things to the other side. So I end up with 5x squared equals 10 by adding 10 to both sides. Dividing both sides by 5 gives me a perfect square. X squared is equal to 2. And then when I take the square root, I get plus or minus, and then the square root of 2 is simply square root 2. Well, this works nicely if you have perfect squares. In fact, the perfect squares can be even a little bit more complicated, like x minus 1 squared is a perfect square, and so if that equals 9, one thing that you can do with this is simply take the square root. The square root of x minus 1 squared is x minus 1, and on the other side we'll be taking plus or minus the square root of 9. And that simplifies. This becomes plus and minus 3, and this is really two equations. One of them is x minus 1 is 3, or x minus 1 could be negative 3. So if I add 1, I get x is 4, and in this case if I add 1, I get x is minus 2. And you can always go back and check that this is true. 4 substituted back into the original equation, take away 1 is 3, and 3 squared is 9, and negative 2 take away 1 is negative 3 squared is also 9. So both of these solutions check to be real solutions. If the equation gets even more complicated, we might have to create our own perfect squares, and we do that by completing the square. So if we look at this one, we could try factoring it like we would do in the last video. And so you want two numbers that multiply to negative 12. And we can factor because it equals to 0. We can use that equals 0 trick. And I'm looking for two factors that add up to positive 8. So maybe 1 times 12 or 2 times 6 might work. Except it's got to be a negative. So it's either negative 2 and positive 6, which doesn't equal 8, or it's plus 2 and minus 6, which also doesn't equal 8. And 3 and 4 doesn't work. So it turns out that this is a does not factor, but amazingly enough, there are still solutions, or there could possibly still be some solutions. So let's see if we can use the square root method to find them. Well, what I want to do is complete a perfect square. So this piece here is the part that makes a nice perfect square. So let's leave that on the left-hand side and move this 12 by adding 12 to both sides to the right-hand side. Now, what number would have to go here to make a perfect square? Well, half of this value squared, so add 16. That would make this a perfect square. It would make it x plus 4 all squared. But I can't just add 16 to one side without adding 16 to both sides. So on the right-hand side, I now have 28. It's very similar to what we were doing in the last unit. Now I can solve this much like I did the solution before. I take the square root, and I get x plus 4, and I take the square root, I get plus or minus the square root of 28. And there's a couple different ways that you can do this. I can break it into the two equations like I did before, or I can just simply subtract 4 on this side and subtract 4 on this side and get x is equal to negative 4 plus or minus the square root of 28. By the way, the square root of 28 is like 4 times 7, which is 2 root 7. So I'm going to rewrite that as negative 4 plus or minus 2 root 7, just to be a little bit more simplified. Let's take a look at one more complicated one, and maybe write the steps down to it so that you can see exactly what I'm doing. So my goal is to use that square root method. I need a perfect square on the left-hand side. To get a perfect square on the left-hand side, I think about these as a and b and c values, and the very first thing I do is move my c value over to the other side. I'll call that other side the right-hand side, RHS. So I get something that looks like this: 5x squared minus 3x equals 1. I add 1 to both sides. Adding 1 cancels this one out and moves it over to the other side. Okay, the next step I need to do is factor out the 5 from these two terms, so I'm factoring out the a value. Now, because I have an equal sign, one thing that I can do is just divide both sides by 5. In this case, my step will be to divide both sides by a. And so I divide this one by 5, I divide this one by 5, and over here on this right-hand side I divide this one by 5. Okay, now I complete the square, and completing the square requires you to take half of the b value, and then you need to square that, and that will give me 9 over 100. But I can't just randomly add 9 over 100 to one side. The equation won't be equal. It won't be balanced, so I would also have to add 9 over 100 to the other side. So for step 4, I added that value to each side. This completes the square on the left-hand side and gives us x minus 3 over 10 all squared. And on the right-hand side, I combine the fractions together. So on the left-hand side, step 5, I get a perfect square, and on the right-hand side, I combine these together. So I multiply this by 20 to get a common denominator. I multiply this by 20, and I end up with 29 over 100. And now I can take the square root of both sides. Again, I have to remember to take plus or minus, so I get the square root, which is just the inside of x minus 3/10. And now I take the square root of this side, so you get plus or minus, and the square root of 29 is the square root of 29. It doesn't simplify, but the square root of 100 is 10. And now I solve for x, and that means I add 3/10 to this side, and I add 3/10 to this side. So on the left-hand side, I get x, and on the right-hand side, I have a common denominator of 10, so I can just add these two top parts together. So I get 3 plus or minus root 29, because there's two solutions. There's 3 plus root 29, and there's 3 minus root 29 on the numerator. All of that is divided by 10. So 29 is about 5.4 or so. So it's 3 plus 5.4 divided by 10 and 3 minus 5.4 divided by 10. Those are approximately the decimal places that you would get for a solution that you will have a little bit of a hard time checking, but you could substitute in here and calculate that, and it should be equal to exactly 0. Okay, we've now learned another method to solving these quadratic functions, so we'll get to practice in class. See you then.